Good morning, everyone. This is BremSter, and today I'm coming to you with a puzzle that is apparently Thripple the Fun. This is Thripple the Fun by Flinty, and this is a play with the normal zipper line constraint, which I've struggled with in the past, and I could see getting this one wrong quite easily, so we'll see how it goes. Don't really have anything to call on the channel at the moment, except for I may need to take a break sometime soon. I've got a lot of stuff coming up, and we'll see how that goes. So there may be a break on the channel. We'll see how it all goes. So let's have a look at Thripple the Fun. So we've got normal Sudoku rules apply. So in every box, in every row, and in every column, the digits 1 to 9 get placed without repetition. And then we've got these Thripper lines. Not a fan of the rules as written, but anyway, they're like zipper lines, but there are 3 legs rather than the 2. I would prefer if the puzzle didn't require you to know what zipper lines were, but whatever. So what it means is digits an equal distance from the center of the Thripper line summed together to the same total, which is the value of the digit placed in the line center. So if we use this line as an example, this cell here has the same sum as those cells there because these are all 1 away from the center, and these cells here are 2 away from the center. So green will have the same sum as yellow, which will have the same sum as blue. And then this, which we will call orange, will have the same sum as green, which will have the same sum as yellow, which will have the same sum as blue. Absolutely fascinating how this is going to work. And with these all being over the place, I have no idea how this is going to hang together. So I'm going to restart the puzzle to restart my timer. Let's give this a shot. The only place I can see where I can actually jump in on anything is this one here. Actually, this one here as well, because these 3 digits, which all have to sum to that, all see each other. So the minimum is 1, 2, 3. So this is 6, 7, 8, 9. Same here. The minimum of those is 1, 2, 3. So this is 6, 7, 8, 9. But I can't do that in any of these other ones because those 2 could be the same digit. So the minimum here is 4. The minimum here is 4 because I could go 1, 1, 2. So I don't know how to do this. Now, there must be at least a... Oh, actually, no. This is a 7, 8, or 9. Because there must be at least a 6 on this line. Because the minimum I could put into the... Ooh, this is actually more restrictive than I thought. Because the minimum I could put into these are 1, 2, 3, 4, 5, 6. And wherever I put the 6, at the other end is going to have at least a 1. So if I was to put, say, the 6 here and the 1 here, I still need to add another digit. So this is at least an 8. Ooh, that's interesting. So this one is 8 or 9. I was actually thinking this is less restricted, but it's more restricted. But now, can I put a 7 on this line? Because with zipper line, well, I can never put a 9 down here. So 9 is in one of these 3 cells. Can I put an 8 on this line? If I put an 8 on this line, no, I can't because I've got to add 2 other digits. Now, can I add 7? If I was to add, I can't put 7 down here because the same is true here. I can't put 7 down here. The question is, can I put 7 up here with, say, 7, 1, 1 and this be 9? And I think I can. But I can put 8. 8 is in one of those 3 cells. 9 is in one of those 3 cells. And I can't put 7 here, but I think I can put 7 up here. The other possibility, or the question is, can this be 7? Well, this can't be 8 or 9. If this was 8, I'd have to add 2 more cells to it and keep it down to at least 9. This is an 8-9 pair. So the question is, can this be 7? Because none of these can be 7, because the minimum I could add, if this was 7, the minimum I could do here is 1 and 2, and this would need to be 10. Same here and same here. So I'm either forcing 7 up here, or this is a 7. Can that be a 7? And I think the answer is yes. If I was to go 1, 1, 1, 1. So I can put 7 down here. So 7 is in one of those 4 cells in the column. Okay, this is fascinating. 8 and 9 cannot go on any of these lines. Maximum I can put onto these is 6. So this is about 7s, 8s, and 9s. because you can never put an 8 or a 9 on a line, except for in the middle cell, because you have to add at least 2 other digits. So the 8s and the 9s across in row 9 are in these cells. I've got an 8 or 9 to put in those. I can't put 7 on those, because the minimum these could be is 1 and 2. So if I put a 7 there, the minimum those could be is 1 and 2. So 7, 8 and 9 can't go there, but I can put 7 there. I can't put 7 there. These are weirdly restricted, because the add-ons to these all see each other, even though they're in different boxes, they're in the same column. So these can never be 7, 8 or 9, because if I put 7 here, the minimum here is 1 and 2. So I can't put 7 in any of those. So 7, 8 and 9 are in here, apart from that one. So 7 is in here. Wait, 7 is in here. I can't put 7 in here because I'd blow this total. I can't put 7 in here, I'd blow this total. I was about to say I've got an X-wing on 7s, but I don't, because 7 could go there with this being 1, 2, 4. So, I don't understand. So what's the minimum? As I said, this could be as low as 4, couldn't it? I mean, it'd cause a problem if it was. If I did 7 with 1, 1... Well, there's got to be a 7 on a line, either here or here. And whichever one it is makes one of these a 9. So that's an 8. Because if I put a 7 here, then I have to add 2 1s to this line to make that a 9. But if I don't put 7 up here, I can't put 7 down here, I'd have to put 7 here, which would mean I'd have to put 2 1s on this line, making that a 9, and both of those cells see that one. That's an 8. That is a 9. There's no 9 here. There is now a 1 in one of those 3 cells, because those all need to see each other. So those 3 all see each other. And if I don't use a 1, they'd be 2, 3, 4, which is 9, and it can't be 9. This now can't be 9. So I can't even put a 6 on this now, because 6 would need 1, 2, which would need that to be a 9. So but that was cool. I'm trying to see how to use it. 9 is in one of those 3 cells. Can that be anything other than 9? If that was, say, a 7, then all of the digits on the lines would need to be less than 7. And they'd need to be less than 7 by at least... If this was a 7, I could never put a 6 on the line. So 9 would go in here and 6 would go in here. So with a normal zipper line, you can't put a digit equal or higher than the digit that is in the center on the line. This one, there's a 2 difference, but with some of them like this one, there's a 3 difference. So I can never put a digit higher than 5 on this line, If I put a 6 anywhere, no, I could put a 6 here because I could go 1, 1. No, I can't do that. I could put a 6 here and go 1, 1 because then I could put a 1 there. But I couldn't go 6, 1, 1 and an 8 because if I put 1, 1, there's no 1 on this. So that's a maximum of 5. Sorry, this is breaking my brain. This is completely breaking my brain, and I think I'm looking at this the wrong way. 9 in this row now is in one of those cells. 9 in this box is in one of those. 9 in this box is in one of those. If that's a 9, that's a 9. If that's a 9, that's a 9. Then 9 in this column would be in one of those. This is not helping, is it? No, I'm not seeing it. If that's a 9, that's a 9, which is interesting. But if 9 isn't here, it's in here, which puts 9 here, and that's not a 9. And then 9 would be here. No, it could be here. I don't understand the puzzle. So 8 is up here. 8 is in here, but 8 doesn't need... So is it the sum of these lines? Because these lines sum to 27. Wait a minute. Because these are 3 times 9, which is 27. But the minimum of these is 21. Does this have to be 1, 2, 3? Is that... The minimum these can be is 1, 2, 3, 4, 5, 6. 1 plus 2 plus 3 plus 4 plus 5 plus 6 is 21. The minimum these can be is 1, 2, 3. And if I add 21 to 6, I'm at 27. Which is what this sums to. This has to be this. So this is 4, 5, 6. This is 1, 2, 3. And this is a 7. So this is a 9. And now these sum to 20. What? These are 7, 8, 9 with no 9 there. Whichever one of this is a... This is... And now these have to sum to 20. I'm sorry, that broke my brain. 9 is in one of those two. These have to sum to 20. I don't know how to repeat that math because these saw each other in a way that these don't. Because here I can get as high as 11. Except with that 7, these are both 1. So those, which means there's no 1 there, that's the 1. So these need to sum to 8. So they can't be 4, 4. So there's no 4 there. So this is either 5, 3 or 6, 2. There's no 1 there. That's a 1. So these have to sum to 8. So there's no 4 there. This is a 4. Oh, this is insane. So these need to sum to 5. So those are different. So whatever that is, this is the different digit. So these are a 2, 3, 4. So this is blue. This is yellow. Yellow is... Sorry, this is breaking my brain. These have to sum to 9. The minimum here is 2 and 2. Now, if I put a 3 here, these would have to sum to 6, which I could use 2, 4 maybe? I don't know. Sorry, this is completely melting my brain. But the minimum here is now 4. So the maximum these can sum to is 5. So those are 2, 3 with 4. This is blue, and this is yellow. These are 5 and 6. Five and 6 go in here. So these are 5, 6, 7, 8. So what the heck is happening here? I can't put a 7 or an 8 on this line. I don't even think I can put a 6. I can't even put a 6 on this line. I've already looked at that. Because if this is a 6, one of these would have a minimum of 1, 2, needing that to be a 9. If this is a 6, 8 doesn't work, 7 doesn't work, obviously. Even 6 with 1, 2 or 1, 2 would need that to be a 9. That's a 5. And one of these is a 1, 2, making that an 8. There's no 8 here. There is now a 2 on this. The 5 needs a 1, 2. Either here, and it can't be here because of the 1 here. So this is 2 and 1, meaning yellow is 3 and blue is 2. There's no 5 here. There is a 6 in one of those two, but now I can do this math. 1, 2, 6. This is 5, which I hope works. 5, 3, 1. That all works. So 6, 1, 2 is 9. 5, 3, 1 is 9. 4, 2, 3 is 9. Holy cow. How did I find that? Well-designed puzzle is how I found that. Got to put a 3. There's no 1 here. There's no 2 here. This is a 1, 2 pair. Because I need a 1 or a 2 on a 6 or a 7 arrows. This is 3 or 4. So these are 3, 4, 6, 7. But this can't... Minimum here is 2 and 3, which is 5. So this can't be any higher than 3. This is a 3, taking 3 out of here. And then this needs to be 2 and 3. And I can't put the 2 there. This is the 3, this is the 2, which sums to 8. Did that do anything apart from complete this? These lines are insane. 3 is now on this line. Actually, by Sudoku, this is a 2, 3 pair. And that adds to get to that. So this is... Well, this can't be a 7 anymore because this would have to be 1, 2, 4, and I can't make it 1, 2, 4. For this to be 8, in order to add to 5 to get to 8, I'd need another 3. So this is either a 1 or a 4 in order to make this 6 or a 6 or 9. Okay, but if this is 6, this is 1, 2, 3, and what do I put in here? These would be a minimum of 4 and 5, and I can't make that work. This is a 9, which means this is a 4, which puts 4 down here. These now need to sum to 9. But the minimum these could be is 1 and 5. But the minimum this could be is 1. But if it's not 1, it's 5. But I have to put a minimum of 5 in here, and I can't do that. So this has to be a 1, which puts a 1 in one of these two. But if I don't... So these have to sum to 8. I could use 1, 7. I can't use 2, 6. I can't use 3, 5. These are 1 and 7. And the 1 makes that the 7, which makes that the 1, which means that's the 2 and that's the 1. The 7 makes this a 6 and this is a 3. There's no 6 here. This is a 4, 7, which puts 4 right there because I can't put 4 in any of those and I can't put 4 in any of those. And that sees there. That's a 4, which puts 4 in one of those two. This is crazy. 1, 3, 1, 3. 1 and 3 are in these cells. 1, 1 puts 1 here. And 3, well, that 3 just took 3 out of there. Okay, well, that's unhelpful. But this can't be a 3 anymore. So what is this triple? 2, 5, 8? Well, this can't be an 8 because I can never put 8 on one of these lines because it'd be 8 plus 1 plus 1, and this can't be, these can't be 1 anyway. So this can't be an 8. Even 5, 2, 2? Well, this can't be a 2. Minimum here is 4. 5 plus 4. This is a 2, taking 2 out of those. Because if this was 5, then the minimum these could be is 2 and 2. This would need to be... Oh, hang on, let me check that again. If this is 5, oh no, the minimum here is 4. 5, 4, this would need to be 0 and it doesn't work. So this is 2. Okay, so take 2 out of there. So this is 1, 2. This is a minimum of 3. This is a minimum of 4. So I've got 2 plus 4 already. So this is at least 7. So this is 7, 8, 9. And that's assuming that's a 1. So because 2, 4, 1. So this can't be 7 because this can't be 1. Minimum this... Well, the minimum, this is 2, or it jumps to 5. And if this jumps to 5, with that being a minimum of 4, it doesn't work. That's a 2. So 2, 2, this is 4 or 5, making that 8 or 9. This is crazy. 4, 7, 8... 4, 7, 8 in there. Must contain a 4. So this is 3, 5, 6. So this is 3, 5, or 6. It can't be 9. And 6, minimum here is 5. And it can't do 5, 5. Minimum here is 5. So this is 3. So this is 1, 3. So we're at 4. So this is 4 or 5. And it can't be 4. This is 5. So this is 5 plus 3 plus 1. So this is 9, which is 2 plus 2 plus 5. So this is the 8. This is the 5. The 2 looks up making this the 3 and this the 2. And I think I've done all the lines now. The 9 takes 9 out of there. This is the 9. I had that a while ago. I just didn't use it. 1, 2, 3, 4, 5, 6 go into those. The 5 looks up making that the 6 and that the 5. 5, 6, and 9 go into those. So this is the 5, this is the 9, and this is the 6. This column is missing 7 and 9. So we have 7 and 9. This box, 4, 8, 9. So this is a 4, 9. This is an 8. This row is missing a 6. So these are 5 and 8. So we've got 8 and 5 because of the 5. These are 4, 7, and 9. Oh, this 6 makes this the 6. And this 8 makes that the 7, taking 7 out of there. This is a 4, 8, looking up, making that the 7 and that the 8. This 5, of course, makes this the 6 and this the 5. The 8 makes that the 4 and that the 8. This row... missing a 9. So these are now 4 and 7. The 9 makes that the 4 and that the 9, which makes that the 7 and that the 4. This column seems to be missing an 8. So these are 6 and 7. We've got a 7, so 6 and 7. This row is missing a 6. So these are 1 and 3. So I can use, oh, okay. So, yep, 3. Oh, it's not 1 and 3. Forget that. But it is missing a 3. And that 3 is saying that's the 3. So this is now a 7, which means that's the 4 and that's the 7. I do need to put a 4 in, and that 4 I put in the 8, and that is the solution to the puzzle. It's had 10,000 solves. I'm expecting this had a CTC feature I did not know about. So I'll go looking for that and see what I missed. But that was amazing. 23 minutes. I'm pretty happy with that as a solve. That was stunning. That was absolutely stunning. That was really cool. Thank you, Flinty. Yeah, I'll go see what I missed. 10,000 solves is an amazing amount of solves. That was absolutely great. It's been out for about half a year. I did know that this puzzle had been in my queue for a while, and maybe I missed the opportunity to get in first, but what a puzzle. What a great, great puzzle. Took me a long time to understand what was going on, but as soon as it clicked, this 27 trick took me way too long to see it, but once I saw it, everything started falling apart. Beautiful. Absolutely beautiful. Thank you, Flinty. Thank you, everyone, for watching. Sorry if you've seen this before, but this is well worth a revisit. Yeah, and as always, good luck with your solving.